Okay, hello and welcome to BYJU'S JEE Advanced. So my name is Mrinal, and today we are doing a live session on the analysis and the questions that have appeared in recently concluded JEE Advanced exam. All right. So if you first we'll talk about the analysis of the questions that have appeared and the topics from where all these questions have come from, and how the pattern of JEE was, what type of questions were there, was it easy, was it difficult. We'll talk about all that, but first let's talk about the topics from where all these questions have come from. So if you look at this JEE 2019 Advanced, so most of the questions were from mechanics. So mechanics had approximately around 11 questions. The second one was from electromagnetism, and this is what we can expect in JEE, right? So most of the question, if you have seen the pattern generally in advance, you get most number of questions from mechanics, and then the second most important topic is electromagnetism. Right now, the third one is thermodynamics, from where 4 questions were asked. So thermodynamics includes your KTG, your thermal heat transfer, and all those stuff. And then you have questions from modern physics. Modern physics includes that atomic structure, but atomic structure, only one question was there, basically that too from transition of from one level to another level, right? And if you talk about other topics that was important was optics. So optics, approximately 4 questions were asked, 3 of which were from geometrical optics, and 1 question was from wave optics, where you have to talk about the fringe width and other stuff. Fine. So moving on, if we talk about the portions from 11th and 12th standard examination, most of the paper was seen to be bending slightly towards the 11th side. But yes, there were of course some good questions from mechanics, which was slightly on the difficult part, but you know, most of the questions were from 11th. That was like 20 questions were from 11th, but only 16th question is what could make up for 12th standard part, right? So for those of who you are preparing for JEE Advanced for the next year, please remember this, that 11th standard topics are very, very important, right? Especially thermodynamics, your mechanics, your SHM and waves, all these, if you're able to cover it, you'll definitely do a very good job in your JEE Advanced examination, right? So talking about the difficulty part, overall, if you see, this paper had a moderately difficult level. We can say that some question were easy, but then there was some concept involved. So it was not like that you can just take a formula and substitute it and get the answer directly. So there was no question like that. But yes, all these questions, even though they were easy, involved some amount of concepts where you had to think before writing a formula or before applying it, right? So if I can talk in terms of percentage, only 8% of the questions were what we can term it as easy. That's around 2 to 3 questions, right? Now, most of the questions, around 19 questions, were moderate level. Now in moderate level question for JEE Advanced, it includes multiple concepts. So multiple concepts means that you will have something from mechanics, and then there is something related with optics or photoelectric effect, and we'll see the questions as we progress in the session. We'll be solving some problems as well, so you'll come to know that what I'm talking about. But 53 questions, if you see, were of medium level, and 39% of the question were difficult. Now these difficult questions actually required some kind of advanced stuff, where you had to apply the formulas. The calculations were also lengthy, so some of the questions that we have taken for difficult was because certain calculations were difficult. All right, so moving on, let's start with the questions, right? So the first question that we have is, it talks about a hypothetical system. So we have to imagine a system wherein we have the angular momentum and the mass is dimensionless. All right, so these 2 quantities are told to us to be dimensionless. Fine. Then which of the following is true? So we have a number of options given over here, right? And we have to check which of them is true. So this was one of the question in this exam. So let us think about how do we do this problem. So essentially you are given 2 information. Number 1 is that my mass, the dimension of mass is 0, and the dimension of angular momentum is also 0. Now if I can write the expression for angular momentum, L will be equal to mvr, right? So if L is equal to mvr, I can write in terms of dimension as m to the power 1 this V is equal to L T to the power minus 1, so this will be equal to L 2 T to the power minus 1, and R I have already taken 1 L from R, right? So this will be the dimension of my angular momentum, right? And it is told that it is supposed to be dimensionless, so this has to be M0, L0 and T0, fine. Okay, so this has to be dimensionless. Cool. Okay, so now of course if you compare, this mass dimension is already told to us to take it as 0, right? So I can just strike this off. So I'm left with L to the power 2 T to the power minus 1, and I'll put it in dimension, equals to L to the power 0 T to the power 0, right? Okay, now if you compare this, I can write L to the power 2 T to the power minus 1 equals to 1 second. Yeah, I can write this as L to the power 2 T to the power minus 1, fine. So I can write, and the other side we have got the unit dimension, fine. So I can write this as L square, that is L to the power 2 in terms of dimension equals to T to the power 1, fine. Okay, so now once we are sorted with this, all I have to do is wherever I am going to get a dimension of T, I'll replace it with L. Now why I have to do that? Because if you see all the options, that first option is about the linear momentum, second option is about the energy, third option is about the power, and fourth option is about the force. So all these options are expressed only in terms of dimensions of length, right? So all these are expressed only in terms of dimensions of length. So I have to express entirely, wherever I'm going to find time, I just have to replace it with L. Okay, so let's get started. Now if I talk about this linear momentum P is equal to m times of V, fine, we know this, right? Now if I want to write the expression for in terms of the dimensions, I can write this as m L T to the power minus 1, right? Now m is of course 0, right? So I have only left with L T to the power minus 1. Now I know this relation over here, right? So I can write this as L, and T to the power minus 1 can be written as L to the power minus 2, right? So I get, this is L to the power 1 and L to the power minus 2, right? So I am left with the dimension of P in my this hypothetical system of unit with L to the power minus 1, right? Let's check. The linear momentum varies as L to the power minus 1. Absolutely correct, right? So you see, what we have done in this question so far is we have just taken the situations that is given in the question to us, and then we have built up a hypothetical system. We wrote time, the dimension of time in terms of length, and then finally we are just equating in different physical quantity, right? So we have checked for one, so option A is correct, fine. Now let's go to the second option, that's option 2. So if I check option 2, option 2 is basically talking about energy. So it tells that the energy varies with L to the power minus 2, right? So we have to check whether this is true or not. So if first I'll write the general expression for dimension of energy. So energy is nothing but we can have the dimension of work done, right? So if I write energy as E, so E will be equal to dimension of energy, E will be equal to, I'll do it on this page. So dimension of energy, if I write E, will be equal to m L T to the power minus 2 times of L. So energy is basically, or work done is equal to force into displacement, so is the energy, right? So I can write this as m L to the power 2 T to the power minus 2 in form of dimension, fine. Now mass is dimensionless, right? And we know how to express time in form of length, right? So I can write this as L to the power 2, and T to the power minus 2 will become T to the power minus 4. So this will be minus 4. So overall, if you see, sorry, this won't be T, one more time, fine. So I have written m, the dimension of m is 0, right? So I need not write that m, so I'll write L to the power 2, and T to the power minus 2 can be written as L to the power minus 4, right? That's what we have got in the last relation, right? So overall, if you see, we end up with writing L to the power minus 2 will be the dimension of energy in the new system, right? Now let us look at the option, what it was. So the energy varies as L to the power minus 2. Absolutely correct, right? Again, option B is correct as well, right? Now let's talk about the third thing, that is power, right? So if I have to write power, power is equal to force times of velocity. So P is equal to F into V. All I need to plug in the dimensions again. So I'll write M L T to the power minus 2. That's the dimension of force, and velocity is L T to the power minus 1. Fine. Okay. So now what we have to do is, again, mass is, of 0 dimension, and I get over here as L to the power 2 and T to the power minus 3, right? And if it is T to the power minus 3, in terms of L, it will be L to the power minus 6, correct? So it will be L and L to the power minus 6, correct? So overall, if you see, I get a dimension of L to the power minus 4. So that's the dimension of my power. Now let us check what is given in the option. Yes, the power varies as L to the power minus 4. Again, we have got it correct, right? So C is correct as well. Now let's check for D. So D is basically force. So force is, dimension of force is M L T to the power minus 2. Fine. Again, we have to write the dimension of mass as 0, and L is L, we have 1, and T to the power minus 2 can be written in terms of L as L to the power of minus 4, right? So we have minus 4 here, and we have 1 power over here, so we get L to the power, well, minus 3, right? Now again, if we check the option says the force varies as L to the power minus 5, but what we have got here? We have got L to the power minus 3. So option D is wrong. So the correct options for this question is A, B, and C. All right, so this is the solution. Now if I talk about this question, basically this required just a bit of thinking, right? So all you had to do, if you think about this question, some people might say, okay, this was a difficult problem, or how will we do it? If you look at the first instance, because it talks about a hypothetical system and we are not used to it, but if you just think a little bit about this problem, the only thing you had to work out was to get a relation between the length and time, because things were easy for you. Why? Because the mass was already sorted. It was told to you that the dimension of mass is 0. Fine. So this type of problem in dimensional analysis you can expect in your JEE exam. Fine. So let's move on to the next question. All right. Now this question is particularly interesting. Why? Because it has multiple concepts, and it has got some weird kind of data that is given to us. But first I'll explain the question to you, and then we go on solving the problem. Fine. So in this problem we have a mirror, and this mirror is attached to a spring. Fine. Now there are certain photons which are coming, and they're striking this mirror. Okay. Now because of this hitting of the photon, some momentum is getting transferred and the spring is getting compressed. Fine. So they have told us that the spring gets compressed by a certain value. That's also known to us. Fine. Good. So far so good. All right. So what is asked is, if the compression is so and so, some value they have told us, right? Yeah, 1 micrometer it is, right? So if the spring is getting compressed by 1 micrometer, how many photons are incident on it, right? It's very interesting problem, right? So let's solve this. Let's see how do we go about this. Fine. All right. Now if capital N is my number of photons, I'll take capital N as my number of photons. What I can say is that when a photon comes and strikes this mirror, it has some energy. The energy can be the energy can be written as E, and it has got some amount of it has got some energy E, and it also has velocity of light, right? 3 into 10 to the power 8 meters per second. So that I can write it as C. Now, but how much is the momentum? So momentum for a photon is defined as the ratio of energy towards velocity. So I can write E upon C is the value of momentum that the photon has got when it is coming towards the mirror, and when it strikes the mirror, it will bounce back with the same speed, right? So it will have essentially same amount of same amount of, I can say, momentum, right? So the net change in momentum of this photon will be 2 times of E by C, correct? So we have the net change in the momentum is equal to 2 times of E by C. All right, fine. We are sorted with this much. Now I know E equals to, I can write E as hc by lambda, right? So 2 times of, I can write hc by lambda, and we have one more C here. So the C and the C gets cancelled. So I can write the momentum transferred delta P equals to 2h upon lambda. Fine. So why I'm doing all this? Because I need to find the change in momentum. So with change in momentum, I'll get the force. With the force, I'll know that why the spring was compressed and by how much was the spring compressed. And I know the value of the compression of the spring. So I'll find out that how many photons are required for this much compression. All right. So this is, I'm talking about 1 photon for this case, right? So if this is the momentum that is transferred by 1 photon, then if n number of photons are incident, then what will be the total momentum transfer? Fine. So if n number of photons are incident, then the total momentum will be equal to 2h by lambda times of n. 2h by lambda times of n, right? Where n is my total number of photons. So far so good, fine. Now, where will all this change in momentum go to? So all this change in momentum, that is 2h by lambda times of n, is going to change the momentum of this mirror, and the mass of the mirror is also given to us, that's capital M, right? So mass of the mirror is capital M. So once this change in momentum happens, all this momentum is transferred to the mirror, right? So this I can write as M into V, fine. So this is equal to M times of V. Fine. So I know the photons are losing certain momentum, right? And the mirror gains some momentum. That's why so the mirror will shift, right? Okay. Of course, you must be wondering that why I did not talk about this spring force over it. The reason is that spring force is not an it's not an impulsive force, right? So it will take some time for the spring to react, right? So that's why I'm not considering. I'm talking only at that particular instant. Fine, that's why I'm not taking it, right? But if you notice one thing, at this point of time, let us say the spring was in relaxed condition, it was in its mean position, right? And when it was compressed, it came somewhere over here. So till what time will it get compressed? Till it is being pushed, and a point will come where it will reach maximum velocity, and at that point this spring will stop, right? So if this is the case, I can write this V as V max, right? Okay. So if I can write this expression as V max, then I can write the expression of n equals to M, and V max for SHM, and one second. I can write this expression as 2h upon lambda times n equals to M times of V max, right? Now V max is nothing but equal to A omega, right? For SHM, we know this condition, right, of SHM, that it will be equal to A times of omega. Fine. Now I can write the value of n as, I'll just use the same space. Okay. So I can write n equals to M A omega lambda divided by 2 times of h, correct. So this is what I got. Fine. So now from here, how do I proceed further? So that's what you will be thinking. Now what to do? But if you look at a question, we have been given a weird kind of an expression, right? And they have given us that this expression is equal to 10 to the power 24. Fine. So this expression that is given in your question is for a reason, right? So JEE Advanced has given you this value for a reason. So if you just substitute the values, you will know what the reason is, right? So I'll just take this expression. I can just clear some space over. Okay. So I'll just take this expression and I'll write M A, amplitude is 1 micrometer, so that will be equal to 10 to the power of minus 6 meters, right? And then we have omega, so let's keep omega just like that. And then we have the value of lambda, right? And lambda is given as 8 pi. Okay, I'll just take it on the other side. Fine. So I've got this expression now. Fine, all I need is to substitute the values. Fine. Okay, so I have n equals to m, n equals to m. A is given as 1 micrometer, so that's 10 to the power minus 6. So into 10 to the power of minus 6, and omega, I'll just keep omega as it is, and lambda is given as 8 pi. Lambda is given as 8 pi into 10 to the power minus 6, right? So I have into 8 pi into 10 to the power of minus 6. Fine. Divided by 2 times of h. Now this 2 and this 8 pi cancels 4 times, so I get 4 pi over here, right? So this 2 and 8 will cancel 2 times, so I get 4 pi over there. So I have the expression of m omega 4 pi into 10 to the power of minus 12 divided by h. Okay, so we come across a very interesting juncture in this problem where the value of this 4 pi m omega upon h is given to us. That's 10 to the power 24. So we have to take this entire value as 10 to the power 24. So if I take that value as 10 to the power of 24 into 10 to the power of minus 12, you end up getting 10 to the power of 12. Fine. And the question tells us that if the value of n is x into 10 to the power of 12, right? If the value of x is n into 10 to the power of 12, what is this value of x? So I know the value of x, n has to be expressed in form of x into 10 to the power of 12, right? So obviously the value of x is equal to 1, right? So if you look at this problem, the correct answer was 1. Fine. All right. So let's move on to the next problem. Okay. Okay. Now, this question is of a musical instrument, right? So let me first explain this question to you. So we have this question where we have a musical instrument of different lengths. So the length, they are saying that it varies from L0 to 2L0. Fine. Okay. and they have given us 4 different cases, okay, and the wire is also made up of different material. The mass per unit length that is new is different for different cases, right? So it's first mu, then 2 mu, then 3 mu, then 4 mu, so it changes like that. Fine. Now for the first case, for string 1, length is L0 and tension is T0. They have told in the first case the length is L0 and the tension is T0, and then the fundamental frequency of F0. For the second case, the length of the string is 3L0 for third harmonic. Alright, so you see we have strings of different lengths, fine, but what they're saying is the value of fundamental frequency is same, fine, okay, but they're having different for different lengths. So for third harmonic, in my first case it's 3L0 by 2, for third case it is 5L0 by 4, and that is occurring at fifth harmonic. Fine. So we have to talk about the tensions. Basically the tensions will be different in all these different strings, right? So we have to talk about the tensions, or we have to comment about the tensions, right? And it's a match the column kind of a problem, so we have to see which one matches with whom, right? Now if I write the expression for a fundamental frequency, if I write if let us take first case 1, okay, so in case 1 I'll take the frequency f is equal to, or as they have told us it should be F0, so F0 is equal to when, this is case 1, fine, so this is case 1, so F0 is equal to, the formula is 1 by the formula is actually n by 2 times of L0 root over T0 upon nu. So this is the formula, right? So in first case everything is given as initial condition, so it's told to us that the length is L0, okay, the mass per unit length is nu, the tension is T0, and F0 is the frequency, and n is the number of harmonics that we have to check, right? So in first case they have told that it's only first harmonic, the length is L0, so length, I write L is equal to L0 in first case, and T is equal to T0, right? So I get this formula of F0 as F0 is equal to 1 upon 2 times of L0 root over T0 upon nu. Fine. So we got the frequency in first case. Of course the tension is T0, it's given. So obviously if you look at the option A has to match with P, right? Okay. So if you see this option, so A must match with this T0. It's also given in the question that it's L0 and it's T0, so they have pretty much told you the first answer. Fine. Now let us look at the second one. So in case 2 things change a little bit, right? So we are told that L is equal to 3L0 by 2, fine, and it is the third frequency, fine. So my value of n will become equal to 3 and L is equal to 3L0 by 2, fine. Alright, so if I write, let us say this is, I call it as F2, this will be equal to, if I just substitute in the formula, this formula, right? If I write in this formula, so I get n is over here 3, so 3 upon 2 times of 3 by 2 L0, right, into root over of, let's call it as T2, let's say the tension is T2, and over here it's 2 nu, right? Okay. So this frequency F2 is equal to F0, fine. So all I have to do is just equate it with this F0. So F0 was equal to 1 upon 2 times of L0 root over of T0 upon nu, fine. Okay. Now let's see what all things gets cancelled out, and how we get simpler, a more simpler expression. So this 2 and 2 gets cancelled out, this 3 and 3 gets cancelled out, fine. So we get the final value equal to, if I just cancel this L0 and L0, and if I just square this on both the sides, I get T2 upon 2 nu equals to 1 by 4 to T0 upon nu, right? So this nu gets cancelled, this gets cancelled 2 times, so I get T2 equals to T0 by 2, I get T2 equals to T naught by 2. So let's see which one of the options it matches. Yes, so string 2 has T naught by 2. So I'll just write it down over here. So A goes with P, fine, and we have calculated for second case, so B goes with R, fine. Now we have to check again for the third string and the fourth string, so third case and the fourth case, fine. So let's do that. Okay, in case 3, let me do it over here only. Okay, so in case 3, it's given to us that L is equal to 5 L naught by 4, right? So L is given to us as 5 L naught by 4, fine, and we have the value of mu is 3 times, right? 3 mu, all right, so mu 3, let's call it, fine. Okay, again if I write the formula, F equals to N, and the frequency is the fifth harmonic, right? So the value of N for this case is 5, so I have to write 5 upon 2 times of 5 L naught by 4 into root over of, well, let's call this as, this is case 3, right? So let's call this as T3 divided by 3 nu, fine. So this is my F3, fine. Okay, now this F3 is also equal to F naught. All these conditions are told in the problem, right? So again I'll replace with F naught, so I'll have 1 by 2 L naught root over of T naught upon nu. Again a lot of things will get cancelled out, so this 5 and 5 gets cancelled out, fine. This 2 L naught and this 2 L naught gets cancelled out. Again if I square on both the sides, I end up getting 1 by 16 T3 on 3 nu equals to T naught upon nu, right? Okay, so this nu and nu gets cancelled, so I get a relation as 3 T naught by 16, and this is equal to, well, T3, right? So I get the value of T3 as 3 T naught by 16. Now let's check which of the option matches. Yes, so string 3 goes on and gets matches with RT, so I can write option C. This C matches with my T, fine. All right, so we are pretty much sorted with 3. Now we have got just one last option to go, right? So in last option again you have to use the same formula, all right? So same formula, and they have told us that in this case the harmonic is 14, so only the value of N will be 14, and if you see the value of L naught is also given to us as 7 L naught by 7 L naught by 4, right? And it is 14th harmonic, fine. So N will be equal to 14, and instead of L I have to write it as 7 L naught by 4, right? And if you calculate that, you'll find out, I'll just do it. Okay, so if you just calculate that, let's say this is case 4, so I'll just write F4 equals to, well, 14 divided by 2 into L naught. L naught over here is 7 L naught by 4, and root over of T4 by 4 nu equals to 1 by 2 L naught equals to the fundamental frequency, right? So the frequency that is given in the problem, so T naught upon nu, fine. Okay, so if you see this and this gets cancelled 2 times, this 2 L naught and 2 L naught will get cancelled, right? This will be 2, right? This 2 L naught and this 4 will come in the numerator, so I get as 8 T4 root over upon 4 nu equals to root over of T naught upon nu. Alright, now it's pretty much a child's play. Now if I square both the sides, I'll get 64. I'll get 64, and this will be equal to T4 upon 4 nu, right, equals to T naught upon nu. So again this nu will get cancelled out, right? T4 will cancel out 16 times, and I get T4 equals to T naught by 16. And let's check if any of the options matches. Yes, so D matches with S, so I have got option D matching with S, right? Okay, so we are pretty much sorted with this. So we have A matching with P, B matching with R, C matching with T, and D matching with S. So this is the solution to this multiple choice problem. Fine. All right. Moving on, let's see this interesting problem from prism, right? So we have a prism, and it's told that one of the surfaces is polished, and it has got some refractive index of n. Fine. And then a light ray is going like this. Find the angle of the prism is 75 degrees, and then we have to calculate the value of n square. Fine. So this is what we have to find. Okay, so we have to find the value of n square. Fine. Where n is the refractive index of that coated medium. Fine. Okay, now if the ray is going like this, and let us call this angle as C, so what will be this angle? So when I talk about this angle, I know with prism formula, you know that A is equal to R1 plus R2. So that this angle, I can write it as, this angle I can write it as 75 degrees minus C. Fine, because you know this formula, A equals to R1 plus R2, right? The two angles. Okay, why I'm doing that? Because I want to apply Snell's law at the first edge, right? Okay, so if I apply the Snell's law at the first edge, then I can write, I can write over here as refractive index. The outside is air, so I can write refractive index of nu. So nu into sine theta equals to nu, where nu2 is the refractive index of this glass. So nu2 into sine of 75 degree minus C. Fine. Okay, so I have got this refractive index thing sorted, and so I'll apply this first, and from here you will find that you have got the value of nu2 as √3, and n is equal to, or this, let me call it as n1 and n2. So n1 is the refractive index of the air, and n2 is the refractive index of that particular medium. Now if you substitute the value, because n2 is given to us, you end up getting the value of C as 45 degrees. All right, so if you just calculate, it's very simple, right? Now again, what we are going to do is we are going to apply the same thing on this second surface. So when you apply the same thing on the second surface, you end up writing an expression of sine C, that is √3 sine C, equals to, I can write, because it's TIR as per the problem, I can write n times of sine of 90 degree. Fine. Okay, so I know sine C is 45 degree, so that will be equal to √3 sine C is, C, I have told you that if you calculate from the first expression, you'll get 45 degree. You'll get it as sine C as 1 by √2 equals to n, right? And what was asked is, what is the value of n square? So all you have to do is square it, and if you square this, n square will be equal to 3 by 2, right, or 1.5. So this is what